Alright guys, in this video I would like to explain to us how contactors work, the different contacts in a contactor. If you can look closely, this is a contactor, this one is a contactor, this one is a contactor, and they are of the same make. This is 2-2 contactor. Why do I call it 2-2 contactor? Because it has two normally closed and two normally open contacts. They both have two normally closed and two normally open contacts. So in this contactor, the way a contactor works is when a current is supplied to the coil, a contactor has a coil, okay, embedded inside. The contactor has a coil. So when current is supplied to the coil, it will then, meaning you are energizing the coil. Since the coil works based on the principle of electromagnetism, meaning from the current that is supplied to it, it will now generate a force, a magnetic force, okay, in the coil. So by so doing, it will then drag anything metal that is close to it. Because of that magnetism force that is there, it will drag any metal that is close to it. So I would love to open one of these contactor and show us the inside, what is inside of it, okay, so that you understand it better. Okay, this is how the inside of this contactor looks like. Here, this is the coil of this contactor, okay, this is the coil of this contactor, and this coil has a contact of A1 and A2, meaning negative and positive, okay. It doesn't matter which one you are using as negative and which one you are using as positive. That is one good thing about AC current. The polarities doesn't really matter when connecting, okay. It is only in DC connection that you have to abide by that rule that a positive polarity must go to a positive terminal, okay. But in this one, the polarity doesn't matter, so you can use any of the contacts as your negative and any one as your positive. You can either use the A1 as positive and you can either use the A2 as negative, or the reverse, okay. So this is the coil of the contactor, and here if you see here, if you look closely here, these are metals, okay, and here too, these are metals in this other part of the contactor, okay. This particular metal, okay, is linked to this switch here, this switch here. Look well, if I push this switch, you see that the metal is moving, so it's linked to the switch, meaning once this coil is energized, okay, through electromagnetism, it will generating a force, a electrical force here. It will now drag this metal, okay, since it is magnet, so it will now drag this metal down, meaning when dragging this metal down, it will now close this switch, okay. That's why they say that contactor works automatically when it is energized, though you can as well operate it manually, meaning in that case you don't have to supply any current to it. You can just use the switch here, just press it down, the contact here will be closed, okay. After that, this, if you look well, there are some spring here, though some contactors have bigger springs, maybe just one but bigger size of it. What this spring does is to help return this switch to its original position once current is removed from the contactor, meaning once you've switched off the supply that gives current to this coil, okay, it will now return this switch back to its original position, meaning the contact of this contactor, the main contact line of this contactor is now open, is no longer closed. But once it is energized, it will automatically change to a closed contact, okay. So that is that. So we have three contacts in a contactor. One is a coil contact, which is the A1 and the A2, okay. And after that, we have the main contact, or the power contact. This is the main contact, this one's here, are the main contacts, where you see them labeled as L1, L2, L3, T1, T2, T3. L1, L2, L3 is the input terminal of a contactor, meaning the supply is coming in from the L1, L2, L3. If you are using three phase, for instance, so the supply is coming in there, while the output of it that goes to your load or that goes to the next component that you want to connect it to will go to the T1, T2, T3. Okay, as the case may be. All right, if you look closely, you see that we still have other contacts here in this contactor. Okay, this particular contact is called auxiliary contact, and in auxiliary contact there are only two terminals, which are the normally closed contact and the normally open contact. Okay, so in this particular contactor, though the contactors differs, there are some contactors that doesn't have this auxiliary contact embedded on it. Okay, while others have it as maybe you can just buy any auxiliary contact and then you now plug it on the contactor. Okay, but this one has a auxiliary contact on the contactor. Okay, so in this auxiliary contact, remember that I made mention that this contactor is called 2-2 contactor. Okay, I said that because this auxiliary contact has two normally closed it has two normally closed input, two normally closed output, then two normally open input or output, as the case may be, and two normally open output, so giving it 2-2 contactor. That's why I call it 2-2. Two normally closed, two normally open contact. Okay, so that is that. Those are the three contacts in a contactor: the coil contact, which is the A1 and A2, the power contact or the input contact, which is the terminal L1, L2, L3, as well as the output, which is T1, T2, T3. Then we have the auxiliary contact, which is the normally closed and the normally open contact of a contactor. So that is it for the contactor. Okay, so I would like to show us how this contactor actually close, meaning I will supply a current to this contactor. Okay, to show us how it closes. Okay, this is my power cable. Okay, so meaning one side of this will go to A1 of the contactor and the other one will go to A2 of the contactor. Remember, I made mention that in AC connection, the polarities doesn't really matter. So you can choose anyone that you want to use as a negative and anyone you want to use as a positive. It doesn't really matter. Okay, so let's go. And when tightening a contactor, you must make sure that you tighten it firm to avoid any form of partial contact or anything at all. So you have to tighten it firm. Make sure that the tightening is firm. Okay, you can see that I've connected the supply line to this contactor, the coil of the contactor L1 and L2, and now I want to test it. Okay, to see how this contactor will close. Once it closes, you will see that this switch here will go in, because the magnetic force inside has will drag it in, thereby closing it automatically. Okay, but in the manual aspect, if you want to close it, it's just for you to press in. Once you press it in like this contact, the main contact of this contactor, will then turn to close, because at rest it is normally open. The main contact of this contactor are normally open, meaning even if you put supply here, the output will not be there. Okay, so, but once you close this, the output will then be there. Okay, so let's see how this will work automatically. I will power this. This is my power source. Okay, so I will power this contactor, and you see that this switch will be dragged in. Okay, you can see now that the switch has been dragged in, meaning the current in the coil of this contactor is working perfectly. Okay, so in this case now, the input supply, can anything that you put from this input will give output, because the contact are now closed. If you remove it, it is open now. So that is just how a contactor work. And secondly, before I forget, whenever you go to buy a contactor, and maybe okay, you want to buy a contactor, first make sure that you test the contactor. This is just a way of testing how a contactor works, just to test that the contactor is working perfectly. You just have to supply a current to the coil of that contactor. Then once the contactor closes, it means that the contactor is working. Okay, it doesn't matter the type of contactor that you are buying, all contactors are the same. Every contactor has A1 and A2 contact of it. There's always A1 and A2 contact in a contactor. No matter how big the contactor is, it follows the same principle. Maybe if you walk into a company or any industry that uses panel, big panels, and maybe eventually they open a panel and you see things like this, it is contactors that are there. No matter the size, the shape, whatever it may look, it follows the same principle. A current is supplied to it for it to give output. So that is just the thing. Okay, so thank you for watching.